Good morning, everyone. Thank you for joining us. This is Anurita, your host for the webinar today. We will start the webinar in the next 1 minute. Hi, everyone. Good morning. Thank you all for joining us. This is Anurita, your host for the webinar today. I thank all our participants who've joined us, and I'm confident that each one of you will immensely benefit from the session today. A few points to be noted here would be: during the webinar, we will use quick poll to gain an understanding of few areas related to your asset class. Request you to please provide the appropriate response. You shall be in listen only mode. If you have any questions during the webinar, please write those in the chat window and we shall address them at the end of the session. Feel free to type there as we go. We shall share a copy of the presentation also after the webinar. Before I introduce our presenter, Mr. Sunil Kamerkar, this morning, I would like to launch the first poll question. Which CMMS or EAM software do you currently use? SAP, Maximo, Infor, or Oracle? If you look at the screen, organizer planning poll closer now. It's here. Why is it not coming? The connection is good. Have you lost? Please check your network settings. Have you lost the connection? No. Are you connected on the LAN? Yeah. Thank you. I'm glad to introduce Mr. Sunil Kamerkar, who was our presenter this morning. Sunil has over 26 years of business and IT experience in implementing analytical and other applications for various industries, including utilities, manufacturing, life sciences, oil and gas, transportation, and mining. He is very passionate about strategizing and designing business practices and analytics at an enterprise level, which are an industry benchmark for asset reliability and maintenance performance management. With this, I invite him for the presentation.
Hello everyone, this is Sunil. Anurita, thank you for introduction. So today we are going to talk about, it's an 18-minute conversation, so I wanted to be very quick on and get to the point quickly. So we are going to talk about how one can analyze asset at an asset class level. So if you have a lot of robots, if you have a lot of pumps, you have a lot of motors, then how do we go about it? So I'm going to today, so the objectives of the 360 analysis for any asset class is understand the overall performance, how the asset is performing operationally, safety, quality, delivery, cost, if you are in the manufacturing sector or in any other sector that will related to operations. Then we want to see how the M&R program, including the PM, PDM programs are working for you. And then, of course, we want to know the economics, the cost around the overall investment in managing these assets. We are also, as part of this analysis, we are trying to identify bad actors, exceptions, and outliers at an asset class that can in turn give us the clues for how we can devise best practices and also the areas of improvement. We're also going to talk about some areas where you can do certain forecasting as well as optimizing certain factors like PM interval, etc., or even the inventory. So we are going to talk about various. So I'm going to, for this presentation, I'm going to focus on chillers. Most of you have this chillers as asset class within your facilities, within your plant, etc. And just before I go there, the data that is presented here is all fictitious, so it doesn't reflect any one particular situation because of the we don't want to share customer data. So obviously we are just going to talk about the concept, how we can go about it. So before I go further, Anurita has a poll question.
Rate quality and integrity of your CMMS or EEM and other equipment asset data in terms of accuracy, consistency, and completeness. Would you believe it is excellent, good, fair, or poor? Thank you for your response. We move ahead.
So let's take as an example. This is, in this particular example, this is a life sciences company having sites in New York, for example, and they have multiple buildings, and some of them are for R&D, some of them are for production, some of them are for general facilities. So they are treating this as chiller system. So they have multiple chillers. In this example, they have 6 chillers, and they are active since December 2014. They have also total 24 asset counts underneath that chillers, etc. So we are going to kind of look at a system profile at a very high level. For the last 4 years, they had about 76 work orders. Mainly on the right side, you can see that the corrective work was about 19. General maintenance, they categorize major corrective work as CMs, and the general other things were considered as part of general maintenance. And then there are some other work orders. So that's about 76. The total cost they spent is about $68,000 on maintenance of this, and the labor hours were about 560. So the purpose of this is really you get a very high level of how these entire chillers are working at that particular site. Obviously, you could do it at an enterprise level also, similar analysis. And this is a very, the example here is just to establish a model for analysis or a framework for analysis. So we can get a very high level view at in this particular slide here. So let's go a little bit further. How these assets are performing, during operation. So again, the assets are there. In this case, the chillers are there for certain purpose, and the company is very much concerned about the safety side of it, the throughput that it is expected out of these chillers, and the quality of service that they provide, and the overall cost of operation. So some of these factors are noted down at a very high level. These KPIs are kind of describing how safety-wise, if there are any incidents in the last 12 months, and then any higher in 4 years, if there are any incidents that occurred on count of these chillers. Also we have some alerts, events, and this is something that somebody can view it on an on-demand basis, or how many are outstanding alarms to be addressed, if there are any planned corrective work events that are outstanding, and the safety events, etc. So the purpose of this particular high-level operation dashboard is really kind of give you a sense of how these chillers are operating. Now, most of our maintenance and reliability program, or the PDM program, is really designed to ensure the high availability of the asset and very efficient performance of these assets. So it's important that even though from a maintenance reliability standpoint we have all other things to look at, operations of these assets is also important for us. All right, so let's move on to the PM program. But before I move on to the PM program, Anurita has a quick question.
How do you rate the alignment of your current KPIs, reports, and analytics with your EM strategy? Would you call them excellent, good, fair, or poor? We move on.
All right, thank you, Anurita. So what we have, the question is really interesting, because many a times we have a lot of different reports and KPIs, but are they really aligned with your overall asset class strategy or your overall asset management program? So for different purposes, you may have a little deviation in the way you will analyze the set of assets. So in this case, we are focused around a particular asset class, and as I mentioned, the purpose of the overall objective is to really understand how well are we performing and what are the best practices that we can continue and areas for improvement, so that we increase the performance of the asset. So in this case, we are looking at we are also looking at the lifetime PM compliance. So in this case, in all the chillers, they have 93%, which is pretty good. And then obviously, as you could see, in the first year it was very high, and then they dropped off and they went. But the purpose again is to really see at the overall 4-year period, how did we do it. In the other interesting way to understand the PM performance is to really look at the PM and CM ratio. And the cost involved in this type of ratio. So total cost in the PM is about $4 million, and the total number of work orders is 6,000. So it kind of gives you a sense of how PMs and CMs are aligned. It is also showing you, if you are performing any kind of inspection PMs or any kind of PDM work, in this case, the PDM is also kind of included as part of the PM. So are there any follow-up work orders? So which kind of will determine your overall effectiveness of the inspection program or any other PDM condition monitoring programs, etc. So here it is kind of trying to find out how many total work orders were performed and how many follow-up work orders were created. Trailing 13 months, how much total PMs were performed post-approval, which is, how many PMs were kind of had to be reapproved for various reasons. And then we also look at the compliance of various other initiatives that you may have. At the bottom, we are saying how many PMs got extended. So for various reasons, if you couldn't perform the PM, you want to know why they were not being performed. And then, of course, we are also trying to say if there are any past due PMs. So when I look at the snapshot of this type of dashboard, it kind of provides me very high level PM program level information. It also we can take some of the clues and the analysis. There are some other analysis that can be performed. So we are trying to give you some examples of how you can use certain optimization techniques by which you could do certain level of optimization on PM intervals. So there could be different asset classes like compressors in the entire system, chiller system, or you may have pumps, you may have some other asset classes. We can go and look at each at a component level, at a failure or a job plan level. You can look at the PMs and look at how you can optimize the interval of the this. So in this example here, we looked at the PM intervals, the scheduled PMs, the actual PM, the cost, all of these different, and we performed an Weibull analysis based on that, and we forecasted the actual failures based on the past data. The model was trained based on that, and then MTBF, etc. So the overall, this analysis kind of arrives at about 72 days. Obviously, this can be further verified or can be run through the subject matter expert or the tribal knowledge and can be adjusted. But it gives you a range, or you can arrive at a certain range to try and reduce or increase the PM interval so that you are not over PMing or you're not under PMing. So that's the idea. Most of the time we start the program, we set certain intervals and we just stick with it. But the statistics and the tribal knowledge together you can use to optimize this interval. So instead of 4, for example, if you're doing a quarterly PM, and if you determine that you can have same level of reliability at 4 months, you may reduce your cost by almost 25% because instead of 4, you will do it 3 PMs. So like this, you can address it, different failure codes, different types of PMs at different assets within that system. Like in this chiller system, you may have multiple assets. You could do that. Okay, so let's move on to general maintenance. Here, before I get on to general maintenance, Anurita has one more polling question.
Are you currently using statistical techniques and analysis to measure performance and identify improvement areas? You have 20 seconds to respond to us. Thank you. We move on.
All right. So here general maintenance, which kind of involves around various small work orders that not necessarily major CMs or major corrective work, but it is more of a small corrective works, because that way kind of you can segregate what you are doing on a regular basis versus major maintenance. So this kind of again gives you what the compliance is. this is other than the emergency work, so you can plan this work, and a lot of times planned work will be cheaper than unplanned work. So we are trying to understand how much planned work was done and what the compliance was for that, and also understand the follow-up work order counts, the cost trend on the general maintenance, etc. So the other important thing is, many times if it's a low level work, sometimes we kind of postpone it, and the idea here was to understand if there are any work that was kind of extended or postponed. So that's the purpose of this particular analysis. Moving on, in this chiller example, they also had some calibration program, and the idea was all the instrumentation on these particular chillers, they were trying to understand how the calibration was performed, how many times they had out of tolerance events, and that's really what this particular slide, and this can be used. This was very important from an FDA standpoint in their case, but as you can see, the general compliance was very poor, and then they started improving, and again it kind of fell back. So this tells you the calibration program still needs a lot of attention, and they need to ensure that it is done on a timely basis. So it also looks at the material cost. As within calibration, there is a lot of service cost, and all the material cost is mainly for repairing of these instruments. All right, so let's move on. So let's look at the failure analysis, and before I move on, Anurita has probably the last question.
The last question today would be, do you have a team specializing in analytics to perform statistical and advanced analysis? Thank you. We move on.
Okay, all right. Thank you. And so now let's focus on the failure overall. We spend a lot of money on our PM programs and general maintenance, but let's understand the overall reliability and see how we all are doing. So we kind of tried to understand the money that is being spent on the reliability program, which includes all the PM work, all the PDM work, etc. And so this particular shows in the 13 to 24 months, last 13 to 24 months, how much did we spend, and last 12 months, what did we spend, and this is the lifetime. And obviously these numbers were just to kind of show, this tells you how much these asset classes are costing you as far as maintenance is concerned. And then you can look at the various, the cost in labor cost versus material cost, your PM CM cost ratio, so all corrective work versus all the preventive work, what is that ratio? So obviously it seems that PM is very, very high compared to corrective work. The idea here is, as you can see, the assets are fairly new, so obviously there is not high CM cost, but this type of analysis will provide you a sense of how much are we really spending on PM compared to CM. If we are spending a lot of money on PM and we are still getting a lot of corrective work, then you probably have to review your PM programs. Then also we wanted to understand how much is the unplanned work. Here it could be from a lifetime perspective, number of work orders, as well as the last 12 months and 6 months, etc., just to see how you all are doing in terms of here unplanned work primarily constitutes a lot of emergency work and high priority corrective work which needs to be done quickly without considerable planning efforts, and that's really what we are trying to understand here. And the last is change evaluation quantities, etc., where you had to provide the further details. The last three follow-up work orders, that just tells you if there are any based on your predictive maintenance program or asset condition monitoring program, if you have any follow-up work orders that were performed, and then anything that really costed you a lot of money, that's we wanted to see. So the purpose of this is really to get a high-level sense of how our reliability program is doing. If we do a little bit further analysis, we can now look at, so here, this is the quadrant analysis on the top left, and we are trying to see the number of the average cost per failure and the number of events or the frequency of those type of work orders. And the color indicates the type of failures, and the bubble indicates the subsystem that on which it was done. So this is a very interesting approach where you could really identify, like in this example, anything on this top quadrant, it really reflects that the particular failure is occurring frequently and it is costing you more. So this is the worst quadrant that one can operate. In this quadrant, it is short stops, it is a frequent, so it is costing you less, but it is occurring quite a few times. And so both these quadrants are relatively important in terms of downtime. But in this example, we are comparing cost, but you might as well do it by downtime as well. And here we are also doing by assets. Here it was subsystems, so within chillers, if you have subsystems, you can do it like that, and then by the asset also you could do. On the last corner here, you could see in the last 4 years how your MTBF and MTTR, how it is reflecting. So, for example, here the lifetime is about mean time between failure is 10 because they had a lot of general maintenance type of work. And in the last 12 months, it has improved, and so this kind of gives you a sense of overall the performance is improving compared to the lifetime, because earlier they had too many incidents, so to speak. Again, the MTTR is also, are we responding well to the requests, etc., can be monitored. The other interesting thing is mean time between maintenance, which includes PM as well as CM or any kind of work that is performed on that asset. And that kind of tells you a story around how many times do we touch a system within a certain period of time. And mind you, this is for the entire systems. So obviously, if there are hundreds of, let's say there are, in this example, there were 6 chillers, and let's say we had 20 plus subsystems, and let's say 100 plus assets. So that is what it is going to show you. The other thing we can do a little bit further, you can look at the by problem code. If you're recording problem code for each of these failures, you can kind of look at which problem code is frequently occurring. You can also do replacing asset. If you are trying to replace a particular asset, what would be the ideal life of that asset, or let's say if you're life of that component, and we statistically we try to perform the analysis to provide you what the time you can replace the component. So instead of doing run to fail at a component level, you could replace that component just before it may fail. Obviously, you could do inspection before you would actually replace it. Then same thing is true here. You can predict certain amount of failures based on your past data and kind of look at the predicted count here. And the idea here is more to kind of get a sense of, based on the past data, what would be the failure in the next 10 failures that you can predict. This was the actual failure, and this is predicted. Obviously, there is a lot of error here, but as you keep on improving, the data quality improves, and we get more data to reflect. To analyze. Your error rate will reduce considerably. Okay, so let's move on to spares. You can look at how the spares were utilized across different work order types. You could also look at major maintenance items and the cost that was. So this kind of tells you if there were major parts replaced, etc., and the overall cost for the entire asset class. You could analyze and get a sense of how much these spares are costing you. You could also do the usage versus cost quadrant analysis, which spare is frequently used. So in this example, the filters are most frequently used. It's a low cost item, but it's just being used very frequently. You can also look at the total unit cost, and the unit cost and the total cost. So here you could break it down, your cost by work order types, etc. So if you are using any kind of consumables, you can look at that as well. So the purpose of this was more get a sense by the asset class how this is being used. Same thing, if you have multiple items which are being used, what is the current stock level, what is the minimum, and we can actually have algorithm to set these min and max levels. If you are stocking your own spares, then you could use something like that. So here, based on your reliability goals or the stock out risk that you want to assume, you could actually use a Poisson distribution to arrive at what would be the ideal stock level, and then you can adjust it based on your EOQ or any other areas that you would like to take. But this is strictly based on the failure risk and stock out risk as vis-a-vis your failures, and you can adjust your ability to take risk and decide on the stock level. So this is another example where you could use optimization statistical techniques to supplement your decisions. So this is overall at an asset class, how much money are we spending? The lifetime cost, 13 to 24 months cost, and the last 12 months. And the idea again is to see how much is labor, hours and cost, material cost, etc. So this gives you a high level picture how our the cost, how much these chillers are costing you. And again, we listed all these major events that occurred on these assets. The whole purpose of these analysis, as you can see, it touches all aspects of an asset class. Obviously, there are other areas also you could analyze, but in the interest of time, I just wanted to focus on certain important areas. You could also think about adding some other predictive analytics techniques, how you could get your sensor data, how you could how you can incorporate all your MES data or manufacturing execution or operational data, and then look at the asset from that angle. So all operational parameters, your condition parameters, your maintenance program. So various asset classes can be, asset data can be combined and you can perform. So here I focused on primarily a CMMS data, but we could also do that. And in the interest of time, I just thought that would be the best thing to present. So if you guys have any questions, I'll be happy to answer questions.
Sure. So we have a couple of questions that have come in. The first one is, one of our attendees would like to know, is it possible to compare the Weibull parameters of similar asset classes across an entire CMMS database?
The answer is yes. Short answer is yes. obviously there are some variations. If the asset classes are, the application of those assets are in a similar fashion, it would make sense. But let's say if you have a pump that is pumping water versus it is pumping slurry, or a highly viscous fluid, it may not be the best comparison. The Weibull parameters kind of tells you your overall performance, and it can help you look at the bathtub curves, etc. But the answer is, if the applications are in the similar areas, it would make sense. Sometimes the capacities also matter. If you have a very high capacity pump and then you also have a very low capacity, maybe it is not an apples to apples comparison. So usually we have seen it makes sense to have a similar assets, and in a similar operating conditions, it would be a lot more relevant.
One of our attendees would want to know, how can you write down all failure codes with an FMEA study or a COFA or only experience?
Uh, that's an interesting question. Depending on the line of business and depending on the criticality of the asset and the money that we spend on these assets, what we have seen is different companies take different approaches. Certain level, if we do too much detail, then collecting data becomes extremely difficult. We have to be a little intelligent about which FMEAs, which failure mode is, which PM is addressing which failure modes. First of all, we have to establish that relationship. And once we do that, and if that's an addressable failure mode, then that's probably what you want to code it as part of your failure coding. But we feel that, and this is again, it's a very subjective, my personal opinion is we should have certain hierarchy of failure codes and very manageable failure codes. And the failure codes that are aligned with your PM programs are the best ones, because that's what helps you with analysis. Certain failures are so too generic and you can't really pinpoint, like a mechanical failure or an electrical failure. That kind of, it's too broad a category. There is an ISO standard around some of these failure codes, and really I would leave it to how you are addressing the PM program, and I'll rely more on that, because the data can be aligned for proper analysis if your failure modes are addressed as part of your PMs.
And Sunil, is it necessary to make a criticality matrix first?
Yes, that always helps, because if the assets are critical and you have high number of them, then the asset class becomes an important, that asset class itself becomes very important. Sometimes there are common sense ways of, if you have a very highly expensive or a single point of failure assets, then it's just a single asset. But if you have multiple of those, and maybe all motors may not be critical, or all pumps may not be critical, or robots may not be critical, but as an asset class, if you have many of those or a lot of those, then some criticality analysis just helps you prioritize in terms of the work that you're going to perform, the way you're going to review this analysis, their PM programs, and what could be the best practices, your training program. So a lot of these things can be aligned. Your resources and activities can be aligned based on the criticality of the assets.
Should we make a RAM study for maintenance task times?
Any further analysis or any further study to determine the overall program, plus your PM, the job plans, the PM intervals, all of these things allows you to really give you a very more sophisticated and mature maintenance reliability program. Your job plans can be really well defined. So a lot of RAM studies will allow you further details which can be used in this type of analysis.
We also have a couple of more questions coming in, but sorry, due to the paucity of time, we will respond to each of you individually. Sunil, thank you very much for this, and I'm sure the audience found it pretty engaging. For each one of you, we will keep you updated on our upcoming webinars. Thank you very much for joining us today across time zones in the US and across other parts of the globe. We'll be happy to receive your feedback on the webinar, and if you have any specific topic that you would want us to host the webinar on, please feel free to connect with us for the same. Any service queries are also very welcome, and we will be glad to assist. Once again, thank you everyone and have a good day.
Hey, thank you, Anurita, and thank you all.